Hello, Mr. Pepperell here, and in this little video I'm going to talk to you about resistance and diodes.
So we have previously talked about Ohm's Law, which states that the current through a resistor at a constant temperature is directly proportional to the potential difference across the resistor. Okay. We also found out when we looked at filament light bulbs that not everything obeys Ohm's law. Okay, we get some things which are non-ohmic conductors. Okay, and they don't present that directly proportional relationship between current and potential difference. Okay, like I said, a light bulb is one of those, and also these things called diodes are those things. Okay, so that's a picture of a diode. You might sometimes see this little circuit diagram as well, which represents a diode when you've got a circuit diagram there. Now, a diode is a device that only allows current to flow in one direction, the direction of the arrow, in fact. So in a circuit, current would be allowed to flow this direction through the circuit, but if the current tried to flow in this direction, the diode would not allow it to flow in that direction. So diodes only allow current to flow in one direction.
So if we look at this circuit, if I insert a diode into the circuit, we can see in the direction of the arrow, the current is allowed to flow in that direction. But if I remove the diode and turn it around, the bulb does not light up because the current cannot flow in that direction through the diode.
Okay, if we look at a current potential difference graph for a diode, we can see that it's a bit different from what we've seen before. Okay, if we look at the current potential difference graph for a diode, we can see that the line here starts to curve back towards the current axis. Okay, so as the potential difference increases, that line curves back towards the current axis. This means that the current and the potential difference, well, are they directly proportional? No, they are not directly proportional. Okay, therefore this diode is an example of what we call a non-ohmic conductor. Okay, now looking at the graph again, we can see that if we reverse the potential difference, okay, the current does not flow at all. This part of the graph, there is no increase or change in current whatsoever, because remember, diodes only allow the current to flow in one direction. The resistance of the diode for the current to flow in this direction is much, much higher, so the current is totally negligible.
So there we go, that's a little bit about diodes and resistance. Basically, if the current is going forward in the direction of the arrow, the resistance is low. If the current's flowing the other direction, the resistance is high. As always, any questions, don't hesitate to tweet me at Mr_Pepperell on Twitter and I'll get back to you ASAP. Thanks for stopping by.